So good evening students. So today what we will do some questions based upon the mensuration, right? So I had uploaded a shorts, so I want to show you that how to solve such questions. You need to find the way behind, right? So let us see what was the question. The question was very clear that if two cones are melted together, okay, if two cones are melted and they form a, if two cones are given to us, right, if these are the cones which are given to us and they are melted to form an sphere, they are melted, then this will be forming an sphere, right? So what will be the diameter of this sphere, right? So we have few details with us. What are those details? Let us understand. We have been provided with two things. What? The radius of both the cones, this one, is same, right? The radius of both the cones is same. That is 2.1 centimeter. So we can say this is 2.1 centimeter and the radius of this cone is also let's say R1 and R2 as 2.1 centimeter, right? Now the in the question the second part which is given that the height is the height of these cones have been changed, right? These two cones are having separate heights. What are those? That is 4.1 centimeter and 4.3 centimeter, right? So we can mark it over here that this h1 as 4.1 and this h2 as 4.3 centimeter, right? Now we need to find the, what we need to find? We need to find the diameter of the sphere so formed, right? So we know that these are the two solid right circular cones, right? And for any right circular cone, we know the formula that volume of right circular cone, right circular cone is equal to what? Tell me. It's 1 by 3 pi square h, right? Where r is the radius and h is the height of that particular cone, this cone, right? So we have two cones with us, one with radius r1 and another with radius r2, right? So what will be the volume of the two cones? The volume of the two cones will be same or not same, not equal? Tell me. Since in the formula we can see volume of the cone is directly proportional to the radius square and height of that cone, right? So here we can see the height is h1 and h2, right? Since the height is different, so the volume of these both these cones will be different, right? And what is that? Let us calculate, right? So just writing the formula that, and we will also write the formula of the sphere. What is the volume of the sphere? The volume of sphere, solid sphere, which is formed by, so I had not written the question because I had already uploaded the sorts of that, right? So if you want, you can refer that those shorts and videos. But here I have already taken the data from that two cones melted to form a sphere, right? And we need to find the diameter of the sphere. That is what, right? So we will do one thing. Yeah. So what we will do, we will write the volume of the sphere. What is the formula of the volume of a sphere? The volume of a sphere is 4 by 3 pi r cube, where r is the radius of a sphere and this r is for radius of cone. Mind it, these above are for the cones and the below r is for a sphere, right? So just to identify them separately and to avoid any confusion, let us write this as R1, R2, the value of H1 and H2 for the both the cones, and for the sphere just write it only as R, right? Now the volume of right circular cone is known to us. So let us directly solve the questions now. What's the question? The question is that the two cones are melted to form a sphere. So definitely the volume of both the cones will be jointly add up, will be joined and add up to form the will be equal to the volume of the sphere, right? So now I am writing it, that volume of cone 1, right? Volume of cone 1 plus volume of cone 2, that is, this is 1 and this is 2. When they will add up, they will be equal to the volume of a sphere, right? A sphere. Now what is the volume of cone 1, what is the volume of cone 2, and what is the volume of a sphere? Just put up the formula for cone 1, that is 1 by 3 pi r1 square h1 plus 1 by 3 pi r2 square h2. This will be equal to 4 by 3 pi r cube, that is the volume of a sphere. So writing it with a different color, hope we can write it, 4 by 3 pi r cube, just to distinguish it separately, right? So here this r is the radius of this sphere which is formed after melting two cones, right? And the volume of the two cones will be having the variables r1 h1 and r2 h2. Basically these are not the variables as of now, but in the formula they are treated as variable, and here we are knowing the values of those variables, that is r1 h1 and r2 h2. So just put up the formula. Before doing the further calculations, let's do one thing. Why don't you bring the common terms out? Here you can see 1 by 3 pi is, which can be taken common in the LHS, and here also 1 by 3 pi, the second term of the LHS. So bring those two terms as a common, right? Similarly 1 by 3 pi is here also into the RHS, so you can just bring it common. So we can write it as 1 by 3 pi r1 square h1 r1 square h1 plus r2 square h2, isn't it? We have taken 1 by 3 pi as common, right? This will be equal to 4 by 3 pi r cube. So just write 1 by 3 pi separately. This will be multiplied by 4r cube, right? This will be multiplied by 4r cube. Now here you can see 1 by 3 pi is common into the RHS and 1 by 3 pi is common into the LHS. This will be cancelled out, right? So what we are left off with? We are left with R1 square H1 and R2 square H2, and this will be equal to 4R cube, right? This will be equal to 4R cube. Now put up the values of R1, H1, R2, H2, right? So we are having the values with us. We are knowing R1 is 2.1, right? So put up the value 2.1 square into H1. What is the value of H1? H1 is 4.1, right? You can see over here, into 4.1. This will be added up with R2 square H2. What is the value of R2 square H2? You can see R2 is 2.1 over here. So 2.1 square into H2. What is the value of H2? H2 is 4.3, right? So this is 4.3, right? So this will be, these are the total terms into the LHS, and into the RHS we have 4r cube. So you can see in the entire equation there is only one variable r, and rest of the terms are known to us, right? So we can easily calculate the value of r, right? So just go ahead and do it. So in both these two terms of the LHS, you can see 2.1 square is common, right? So why don't you take it as a common? So just do it. 2.1 square is taken as a common in LHS, and we are left with 4.1 plus 4.3, isn't it? This 4.1 and this 4.3, right? Now this will be equal to 4r cube, right? This will be equal to 4r cube. Now 2.1 square into 4.1 plus 4.3 will be equal to 2.1 square into 8.4. You can just add up 4.1 and 4.3. This will be 8.4, and this will be equal to r cube, and bring this 4 from the RHS to the denominator of the LHS. So you can see here it's r cube. If there will be 3 common terms into the LHS, and when we will take the cubic root, then we are left with our answer, right? So if we, so just think in that direction, it will make our calculation very easy, right? So why don't you cut 8.4 by 4? After just dividing 8.4 by 4, we are left with 2.1, isn't it? Just see, 414,428.1. So into the LHS we have 2.1 square into 2.1. So this will be equal to 2.1 whole cube, right? If r cube is equal to 2.1 whole cube, then what will be the value of r? Taking a cubic root on the both sides of the LHS and RHS, we can see r as 2.1 centimeter, right? R is 2.1 centimeter. So 2.1 centimeter is the value of this sphere, radius of this sphere, that is 2.1 centimeter. But what we need to calculate? We need to calculate the diameter of the sphere. So how to find the diameter of the sphere? We know that diameter diameter is equal to 2 times radius. This is very simple formula, as hope we all are aware of. If this will be equal to 2 times radius, then what is the value of radius? Take it from here. That is 2.1 centimeter, and this will be multiplied by 2. Then we come up with our answer as 2 4 4.2 centimeter. So 4.2 centimeter is the diameter of a sphere, right? So in this way we will solve such questions, all the questions related to volume, because just keep it in your mind that the content, if there is a right circular cone which is solid and a sphere which is solid, then what we will do? We can understand the content inside the cone of both the cones will be add up to form the sphere, and the content inside any solid object is its volume, right? So the volume of both these cones will be added up, and this will be equal to the volume of this sphere, right? And you can just put up the value in the formula of volume of the cone, that is 1 by 3 pi r square h1, pi r1 square h1 plus 1 by 3 pi r2 square h2. Since r1 h1 and r2 h2 are the two different radius and height, these are two different parameters of the two cones, and this will be equal to the radius of that particular sphere, right? R, which is into the RHS. Just put up the value and calculate it, and we get R as 2.1, right? And this 2.1, when we multiplied it by 2, we will get 4.2, which is the actual diameter of the given sphere, right? So hope you all are able to solve such questions, right? We will take some more questions based upon these volumes, right? There is one question that a solid iron rectangular block of dimension and hollow cylinder pipe of internal radius, find the length of the pipe, like that. So let us solve this, right? Now just taking another question now. 1 minute. So before going into the details, I hope you all are aware that the radius, we all are aware that the different formulas which we should know before solving the questions of mensuration is that let us understand for the two dimensional figures first. If we have a square, if we have a rectangle, if we have a circle, if we have a cone, if we have a cylinder, if we have a triangle, okay, if we have a cube, if we have a cuboid, So what are the areas? If this is a square, then area of the square, and this is the side S, all the sides of a square are always equal, and the area of the square is side into side, right? This is the area. And we can also write volume for a three-dimensional object like cone, like cylinder, right? Or maybe the sphere, the cube, cuboid, and this is sphere also, right? So for a rectangle, whose breadth is given and length is given, then area is L into B. For a circle whose radius is R, the area is pi r square. We also should know the 2 pi r as the circumference of the circle. If we have a cone, then there will be no area, it will be a volume, right? And what is the volume of a cone? The volume of a cone, we have already seen that question, that is 1 by 3 pi r square h, right? What is the volume of a cylinder? This is pi r square h, right? Where h is the height and r is the radius. Similarly, for the cone, this r is the radius of the base and h is the height, right? And for a triangle, the area, these are the volumes, right? These are the area. What is the what is the area of a triangle? Area of triangle is equal to root 3 by 4 into side square. If this is an equilateral triangle and this is area of a triangle is also root under s minus a, s minus b, s minus c. If a, b, c are the three values of the three lengths of the different sides of a triangle. If we are left with a scalene triangle, then this formula is applied, where s is the semi-perimeter, which can be calculated as a plus b plus c divided by 2, right? Now if we have a cube, with side a, then the volume, we calculate the volume of a cube. Volume of the cube is side into side into side, that is side cube, edge cube, right? What is the volume of a cuboid? Volume of a cuboid is L into B into H, because it has three different, length is different, breadth is different, and H is also different. The measurements of the three different edges of a cuboid is separate, that is L and B and H, right? Now if we have a sphere, if this is a sphere with radius r, then volume of the sphere is equal to 4 by 3 pi r cube. And if we are left with a hemisphere, if this is a hemisphere, for a hemisphere the volume is 2 by 3 pi r cube, and the surface area of a sphere is 4 pi r square, and half of that, that is applicable for hemisphere. Now there is one more concept of curved surface area and lateral surface area, right? So the curved surface area of this cone is equal to pi r l. L is this slanting height, right? if you know the r, if you know the h, then by applying the Pythagoras theorem, we calculate the value of L as root over of r square plus h square, right? Then taking the square root, we get the value of L. Now this value of L will give, when it will be multiplied with pi and r, this will give the lateral surface area or curved surface area of the cone. Similarly, the curved surface area and lateral surface area of a cylinder is 2 pi r h, right? 2 pi r h. So let us solve one question which is separate to this and what we have discussed. We have discussed almost all the, we have learned almost all the formulas which are using in the, which we are using in the mensuration. There is one more concept of frustum, right? That if we are having a cone and that is cut from the any point in the middle, right? Then what will be the area of the leftover portion? So that is called frustum, just like a bucket, right? So just to solve such questions, to find the volume of a frustum, we know that the volume of the bigger cone before dissection should be calculated, and from that the smaller cone having the vertex, the area, the volume of that cone will be deducted, and we are left off with the volume of the frustum, that is the bucket, right? You can see simply, if if this is a cone, right? If this is a cone and if we are dissecting it from here, then the volume of the bigger cone minus volume of this smaller cone will give the volume of this frustum, this part, right? If you can see the bucket, you can, and just reverse it, you can, you are always find the bucket like this, right? So this area is calculated by calculating the area of the entire cone A1 minus the, sorry, the volume of the entire cone, the bigger cone, minus the volume of the smaller cone, that is A2. Then this will be A1 minus A2, right? Now let us take one more question to understand the details how to solve any further questions of mensuration, right? So we will take one more question, that if the dimension of a metallic cuboid are given and it is melted into a and recasted into a cube, right? Let me do one thing. If the volume, let us solve it over here, right? I'll take some separate paper. I think this will be clear to all of you. So what is the question? The question is that the dimension of a metallic cuboid, a cuboid is given, a cuboid is given like this. This is a cuboid, right? This cuboid is given, and the different dimensions of this metallic cuboid, this is metallic, right? This is metallic cuboid, and the different dimensions are given as 100, 80 and 64. If L equal to 100 centimeter, right, and 80 is its breadth, this one, right, and this was the length, and the height height is this one, and the height of that cuboid is given as 64 centimeter. 64 centimeter h. So we are having the three dimensions which is required for any cuboid, and we have a metallic cuboid, right? So the dimension of a metallic cuboid are given, and it is melted and recast into a cube, right? So this is melted and this is melted to form a cube. You know what is a cube? A cube is having all its edges as equal. That is, all its sides and edges are equal. Let's say A. Then length will be A, breadth will be A, height will also be A. Right? Now, this is melted. This is melted to form a cube. This is a cube. Right? Now, what is the question? The question is that find the surface area of the cube. We need to find the surface area of the cube. Surface area of cube equal to what? The surface area of a cube, we know the surface area is the of a cube is the total area which is in outside. That is, we have six squares, that is 4 along the 4 sides and one top and another bottom. 6 squares which are covering the 6 faces of the cube, right? So all the 6 faces of the cube will add up. So surface area of the cube, to give the surface area of cube as 6 times area of face, that is a square. So this will be equal to 6 into a square. 6 into a square is the surface area of the cube. This we need to calculate, right? This we need to calculate. Now, for that, we should know what is A. Since this cuboid is melted to form this cube, what is the value of A? A of this cube? Definitely, the content, the volume of this cuboid will always be equal to the volume of this cube, right? So use the same formula, that is volume of cuboid, which is given to us, this one will be equal to volume of cube. And what is the volume of cuboid? Volume of cuboid is L into B into H, right? You know the formula which we have learned just now, this one, if you remember. Volume of a cuboid is L into B into H, right? Now, this will be equal to volume of cube. What is the volume of cube? Volume of a cube is side into side into side, that is side cube, which that is also we have learned now. This one, a cube. This is the volume of a cube, right? So this will be equal to a cube. So we know the value of L, we know the value of B, we know the value of H. When we multiply all these three measurements and take a cubic root of that, we get the value of A. So why we are waiting for? Just solve it. Putting the value of L as 100 from here. I am not writing the units over here because definitely it's a centimeter. Into B. What is the value of B? It's 80. And what is the value of H? Value of H is 64. Right? So this is equal to A cube. This is equal to A cube. Now putting up the terms and arranging them, we can write it as 100 into 8 into 10 into 8 into 8 as a cube, because 64 can be written as 8 into 8, right? And 80 can be written as 8 into 10 here. If we can see in the question, we have 8 over here, 8 over here, and 8 over here. 3 times 8 and 100 into 10, that is 3 times 10, that is equal to 1000. So we can write it as 8 cube into 10 cube as a cube, right? Now what we will do? We will take a cubic root of LHS and cubic root of RHS. When we take the cubic root of LHS and RHS, we are left with the value of A as 8 into 10, right? So that is equal to 80 centimeter, right? So 80 centimeter is the 80 centimeter is the edge of the cube, right? Now what we need to calculate? We need to calculate the surface area of the cube, and for the surface area of cube we are knowing that 6 into a square is the answer, right? Is the formula. Putting up the value 6 times a square. A square means 80 centimeter into 80 centimeter. So just multiply it. 64 into 6, 24, 384. So we are getting at 38400 centimeter square as the surface area of cube, right? So we have solved this question, and I hope for any such questions where the volume of any particular geometrical shape is given and we need to calculate the surface area, lateral surface area, curved surface area, or the total surface area, then I think you will be able to calculate it. And what is the total surface area? This is applicable for the cone and right circular cone and cylinder, right circular cylinder. The total surface area concept, we should know it. That suppose we are having a cone, this one. This is having a base as a circle, right? So we know the lateral surface area of a cone is pi r L, and if we add pi r square of the base, this will be equal to total surface area, right? Similarly, if we are having a right circular cylinder, and for a right circular cylinder with a radius r and h height, we know that the curved surface area is 2 pi r h, right? And if we add the area of the circles at the top and bottom, that is equal to pi r square plus pi r square. So this will be equal to the total surface area of cylinder, right? So thank you students, thank you for watching. For any query or questions, just put up into the comment box. I will get back to you and respond all of your queries. And keep on learning, and like and subscribe to my channel. Thank you. Bye bye.